I'm Abby the Maths Tutor, and today I'm going to show you how we can use a function machine to solve an equation that just has a letter on one side of it. I find these really useful to work with because they mean that so long as the letter only appears on one side, we can work to solve any sort of unusual looking equations. It helps pupils think about the order that things happen and also helps them get their head round seeing equations as puzzles to be solved and thinking about reversing the order and doing the opposites. So on this first question, we start off just with the letter X. So here's my X. The very first thing that happens to my X is that it gets squared. I'll put an SQ for squared because if I just put a 2, we won't be sure what it is. So it gets squared. We multiply it by 3. We add 6. Next it gets square rooted. And then we divide by 2. And that will give us 4.5. And what I tend to find when I'm working with children on this is as I build them up, pupils can always tell me what order things happened in, even if it's something that looks weird, like a sort of equation they've never seen before. They can generally figure it out and say, well, this happened and then this happened and then the other thing happened. So that's what this method is based on. We go through, we figure out the order, and then we come backwards. So when we come backwards, we're going to be doing the opposites. So 4.5 times 2. The opposite of square rooting is squaring. Opposite of add 6 is take 6. Opposite of times 3 is divide by 3. Opposite of squaring is square rooting. So now I'll just follow through with the numbers and work it out. 4.5 times 2 will be 9. If I square that, I'll have 81. Take 6 will be 75. Divide it by 3 is 25. And the square root of 25 is 5. So X equals 5. And generally when I get to this stage with someone, whoever's been working through it with me looks quite shocked that they solved an equation that looks like the question here, and it actually felt easy. Right, so moving on to this one now. Here's another equation that pupils will typically see and feel intimidated by. It probably doesn't look like any of the equations that they've spent ages practicing on solving. So that's where this method really comes in. It's when you see something that looks a bit unusual, you're not sure what to do. We start off with our letter X. Because it's in the bracket, we can see that we subtract 7 first. The 5 in front of the brackets means that we now need to times it by 5. Then there's an add 16. The line underneath means a divide. We typically use a line with something underneath it to show a divide, especially when we're working with algebra. After that, there's the brackets around the outside and a 2, so we know we're squaring it, and that will give us 81. So we come backwards. Opposite of squaring is square root. Opposite of divide 4 will be times 4. Instead of an add 16, we will take 16. Then we will divide by 5, and finally we'll add 7. Now we'll put the numbers in. So square root of 81 is 9, times 4 is 36. Take 16 is 20. 20 divided by 5 will be 4. 4 add 7 is 11. So we've solved it and X equals 11. When people have practiced working these out and played around with function machines a bit, what I tend to find is not only are they able to take on equations with all sorts of weird bits in like these where we've got the squaring and the square rooting that you wouldn't ordinarily expect, but what we think of as the standard way of solving equations where you balance each side and do a line at a time and keep writing the equation underneath, they feel a lot more confident on those because tackling them in this way tends to give pupils the confidence that it's just a puzzle and we can just do a little bit at a time, and their confidence that those steps will work. So I hope that's been helpful for you today. Please do subscribe and keep coming back to check out what videos we've got coming up next.